All right, hello, welcome back. It's day 3. If you count the 2 first days, it's like 1A and 2A. Plan today will be, well, you can see here, take a look at the chemistry stuff from yesterday. Did you understand what that last passage was talking about? No? You can still get points. That's okay. Data representation, we're going to look at that today. Talk about turning tables into graphs, seeing a relationship, things going up in a table. What's that look like in a graph? Comparisons within graphs. We'll have to compare a couple, maybe 2 different things plotted on the same graph. And then we'll talk about a really big topic in ACT science will be answer pairs. We're going to see that answers kind of come in pairs, and we need to think about, well, 2 of them are wrong, or 2 of them have some wrong characteristic, I can cross those out right away, get it down to a coin flip. We'll look at keys, and again, you'll have data representation homework number 2. If you struggled to upload stuff yesterday, a lot of the virtual folks didn't seem to upload stuff. Maybe they're waiting to see me in class to do that and make sure they know how to do that with Adobe Scan. You'll see that the due dates in my class are always going to be 2 days after the fact, so you can upload when you're in person. That way you can use the building scanners or Adobe Scan in person if you're struggling to do it at home. So let's take a look at what you did yesterday because I want to talk about a couple of these. This last one was hard. It just was hard because you didn't know what the heck any of this meant. So a few questions I would like to look at. 35. I think it's a lot easier question than people made it. Most likely. Should have been circling a word like that. It's a mathy kind of thing. Where's it the greatest? Some people wanted to read a little more, and you might have read for distance from nucleus. You might have gone back and read that, and you could have found something about the probability of finding the electron. Where is it most likely to be found? If you went back and searched for that, you could have found the greater the value, the DF, the greater the probability of finding it. I would have just picked the tall thing. Question 36. A lot of people ask me about 36. Oh, duh. What is that? Well, how am I going to know if it's classical or quantum? This is that answer pair thing I'll be talking about later. Well, what's the difference between classical and quantum? Classical's U's, quantum's humps. This is humps. I can immediately cross out the classicals. And is it 7 or is it 8? It's a counting game at that point. I think 38 was hard. That was just kind of goofily worded. 38 and 40 are hard questions. You had to think about those pretty hard. But 39, I think a lot of people would have missed because they didn't know what absorb and emit meant. And if you didn't have those, I want to make sure you got those. Absorb is to gain, go up. Emit is to lose, go down. 35, 36, and 39. I thought were pretty easy questions. See where they are, though. They're at the end of the test. You might have guessed on these. So one of the things that we're going to talk about in the course is the need to make sure you do these data representation passages because they're going to be the easiest all the time. So getting into today's work, what are we going to look at? Looking at some more chemistry, but we got a nice table and graph. So we'll look at tables and graphs. We'll look at trends within tables and graphs. And then we'll look at, well, on this question, really some answer pair sorts of things. You'll notice that number 8 has kind of pairs of answers, present, elevated, 1 and 7. And number 12 also has some kind of pairs of answers, present, 10, present, 90, elevated, 5, elevated, 95. And so we'll look at patterns like that. So we're going to switch over to the document camera. Get your pens out, get your practice number 2 out, because we're going to be working here on data representation practice number 2. I'm going to walk you through the whole thing. Remember, you're going to take a timed practice for yourself on the second passage. So let's switch over to the doc cam. Okie dokie, Smokies, let's get after it. We're looking at practice number 2 here. Again, as usual, I'm going to walk you through the first one in its entirety. You're going to do the second one after I do the first one. You're going to pause it. You're going to put a 6-minute timer up. Then you're going to do the second one. You can watch me go through it. So that'll be the plan. As always, I take the staple out sometimes because we're going to need to see both pages at once. And I don't like ripping it because I'm weird. You rip it if you want to. That'll be okay. So we're going to open up these 2 pages at once, and we're going to take a look at this thing. Because when you open the ACT, you're not going to look at it 1 page at a time. That's why it's so much to print in this class, because especially for science, you got to look at 2 pages at once. So let's make sure we're looking at both pages at once. I've got some different colors today, different colors than yesterday. I'll try and put red and pink and in a different place in the order so we don't get them confused. So let's jump right into it. As always, I'm going to be boxing in where to look, circling math kinds of things, and underlining important looking vocabulary. As a general rule, guys, you're going to develop whatever you want, but what I'm doing, you should stick with for a little while here. You might find something that works a little better for you, but you won't know if it works better until you've, done it a few times. So number one, the compound represented in figure 1, you gotta just put a box around it. You always need to know where you're looking. Has a BP that looks like a variable of -30 and a molecular mass of about what? Remember, they're never going to have a question, they're not going to have a question mark. They're having a question mark about half the time on these questions. Some of the time they're going to just give out like a run-on sort of sentence. You fill in the end of the sentence. It's got a blank there. So figure 1, if it is BP -30, what's the molecular mass? We'd look over here, figure 1. I see BP is over here, -30. Well, it looks like it's counting by about tens. So that's -30 right there. I take -30 out, and we're looking at, okay, we must be looking at CFCl, oh, I just drew over it. Yeah, poop. Take it on down, and that looks to be, I don't know, what is that, about 120. So you need to be able to make those connections, and you need to be able to count tick marks. If this is 100 and this is 150, we got to be counting by tens. So that is going to be 120, and we'll go over here and select answer B, 120 AMU. Do you know what AMU is? It's atomic mass units. Do you care? No, you don't need to know that to answer the question. Number 2, according to figure 1 of the following compounds. Okay, so we got to look at a list. Which one has the highest, circle that word highest, boiling point? Okay, so we're just picking the big one. Just go down the list. There's no quick way to do this. So figure 1's right here. We're looking for highest BP, okay. So CF4 is down low, all right, so it's not CF4. CFCl2, that looks to be right here until I drew over it, so it's not that one. CF2BR2, all right, it's not that. CCl4, okay, got the highest of the boiling points of those 3. So, excuse me, 4. You just got to go through the list. Who's highest on the list? There's no real secrets to that one. Guys, the first few questions of the AP Science test should be gimmies. Like, hey, go put your finger on a point sort of thing. Number 3, we get a look at a table now. According to table 1, the relationship. Okay, we're going to have a lot of relationships coming up here. The relationship between molecular mass and boiling point among the compounds, all right, is represented by which of the following graphs? CHCl3, CHBr3, CHI3. I need to find where that is on the table. So here we have CHCl3, CHBr3, and CHI3. Okay. And what's the relationship we see there between molecular mass and boiling point? Well, look what happens. As molecular mass goes up, let's see what boiling point does. Boiling point seems to go up as well. What kind of relationship is that? We call that a direct relationship. As one goes up, the other goes up. So I'm going to go back over here to the problem. I'm going to write that for you. As MM increases, BP also increases. That's A. We call that a direct relationship. As one goes up, the other goes up. Down here, C is not the correct answer, but this is representing something of an inverse. Whereas MM goes up and BP goes down. That is not the correct answer, but that is what an inverse relationship might look like. One thing increasing, the other thing decreasing. All right, so 3 down, 3 to go. Number 4, at 1 atmosphere of pressure. That looks like looks like a math number I might need. The temperature at which CH2I2 boils is, I'm going to circle that word, how much greater than the temperature at which CH4 boils. So I need to find boiling points for those two things, CH2I2 and CH4. All right, well, CH2I2 at boiling point 182, okay. Methane, CH4, negative 162. How far apart are those? Well, you could subtract them. You could do, oh, you don't get a calculator though. You could do 182, you know, you can do minus negative 162. Hopefully you know that subtracting a negative means that it's going to be 182 plus 162. There's really only one reasonable answer here, but I'll show you the math to get there anyway. Answer being H. You don't get a calculator on the ACT science test. You get one in math, but not in science. So you need to be able to like show math by hand. My God, can you think of it? Let's keep after it. Number 5. According to Table 1 and Figure 1. Great. So we got to combine info. So I'm going to write combine sources. If it mentions two things, you're going to have to put them together. The molecular mass of CF4 is closest, circle that word closest, to the molecular mass of which of the following compounds. All right, CF4. So let's first start with the information they're telling us about. Molecular mass of CF4. Where is CF4? CF4 is right here. Great. What's its molecular mass? Look like I get a mass right here about 90. So I got to say, okay, what's closest to 90 in molecular mass? Well, I might look over here at this this table, which has got those other things, and I might say, which one of these is closest to 90? Well, I got two things that look pretty close to 90, but I don't know if either of those are on the list because these are some nasty looking words I got to look at. Dichloromethane. You don't care about those words. They're terrible looking. So you look at those two words, dichloromethane, bromomethane. Turns out only one of them's on the list. The only one that's on the list is dichloromethane. You'll notice that bromomethane is not on the list. So we're going to choose A. We found 90, closest to 90. Which one was closest to 90 on the list? Dichloromethane. Great. And then the last one. The last one is a lot easier if you remember your chemistry and your stoichiometry specifically. The atomic mass of carbon is 12. Based on the molecular mass CBr4 in Figure 1, what's the atomic mass of Br? So we've got, you know, C plus 4 Brs equals some mass. We look over at Figure 1 and we look at CBr4. And what does that look like? I don't know, like 330 or something. Oh, I should have changed colors. Sorry. Changed to blue. Whatever. 330 or something. Okay. So what are we doing there? All right. So I'm telling you that the total mass of this CBr4 thing is 330. And we just told you that C was 12. So 4 bromines is going to be, you know, let's make our math easier. And instead of putting 318, let's put 320. Why would I do that? Because I can divide both of those very nicely by 4 to get my answer that will be H80. That one, I do not expect people to get. Remember, which questions are going to be hard in any passage? The last one or the last two? So if you come across a question at the end of a passage, not the end of the test, but at the end of a passage, you don't want to waste too much time there. So that's a good opportunity to keep things moving. All right, so you got another passage. It's about some trees. Very exciting. No, check that, poison ivy. And the, you know, the nasty chemicals in the poison ivy that make you react. Pause this video for 6 minutes. Try to do the video, try to do the passage as well as you can. Give yourself a real grade. I want to know how are you doing with the real amount of time you'd get. And then I'll come back, unpause it, and watch me go through it. So pause. All right, you've unpaused. Great. Now let's work through this together. Again, rotating through my colors. Number 7. According to figure 3, again, I'm going to box in where I'm going to look. Where am I looking? For the present day CO2 concentration plot, the percent of U uroshols in 2004 was what? Okay. It's a lot of words there. Figure 3. It's right here. Present day. How do I know present day? Oh, I see. Oh, I got present day over here. Looks to be 370. Okay, so 370 is present day. According to figure 3, the present day CO2 concentration, the percent of U uroshols per plant in 2004 was. Okay, present day. U uroshols are the dark shaded one. The dark shaded one looks to be 90. Okay, I can do this. I do it right? Yes, I did. Okay, so we're going to choose on number 7 there, D90. Just hopefully finding the right point on the graph. Number 8, according to figure 2, which plot had the higher percent of original PIPs surviving at the end of the study? I'm going to circle end of the study. You might not think it's a math word, but it is kind of a math word. The end, the beginning, the start, the finish. So dates are mathy things I'm going to study. Circle, check that. So figure 2, higher percent of original PIPs surviving at the end of the study. Okay. So percent of original PIPs surviving. The end of the study is here. Who is higher? The higher one is elevated. How much of a difference is this? I don't know. Is it 1 or 7? All right, let's take a look at the answers. This is our first answer pair. You notice you've got present day pairs, you've got elevated pairs, and you've got 1s and 7s. So you've got kind of these pairs and these pairs, and these pairs and these pairs. We're going to work on eliminating a pair right now. We can eliminate a pair. Who's higher? Elevated is higher. So immediately we can cross out the present day options of F and G because we know present day is not correct. We know it's going to be elevated. So now we've got it down to a coin flip. Are those 1 or 7? Well, looking at those, that looks to be like almost a tick mark, a tick mark or so apart. What's a tick mark? Oh, 0, 20. These must be counting by 5. Each tick mark represents 5. So this is 5-ish, a little more than 5. Got to be the 7 option. Got to be answer option J. So it wasn't the 1s either. So we're going to do things like that where we're eliminating pairs of answers by saying what's the common characteristic between that pair. Number 9 is a weird question, one like maybe you haven't seen before because you just had to read. Based on the passage, which of the factors listed below were the same? If we're ever looking for what's the same, we're often going to have to consider what's different. That's a long bell right there. And what's different is going to be signaled by the word except. If you see the word except, you have just found where the differences are. So based on the passage, which 2 factors were the same for the 2 plots? So you go back here and you look. The poison ivy plants were grown in 2 identical outdoor plots under identical conditions, except for the atmospheric CO2 concentration. So the word except is very commonly used in ACT to signify, hey, this is the thing that is different. So what's different? The only thing that was different was the CO2. So what was the same? The same was the soil type and the amount of water. That's got to be 2 and 3 only. That's got to be answer option C. So need to make sure that we cross out the things that are different, often signified by the word except. 3 down, 3 to go. According to figure 1, from 99 to 04, how did the dry biomass, the 2 plots compare? Dry biomass compare. So what are we going to be doing here? The dry biomass at 370 was always the same, always greater, always less than. We have an equal to, we have a greater than, we have a less than, and then we have the in some years greater than, but other years less than. This is kind of like the no trend option. So we go back and look at figure 1 and we say, well, who's on top? Elevated was always on top. Present was always below. Let's take a look back at how the question words it. 370 is at present. So at present, it was always lower. 370, always less than. 570. 4 down, 2 to go. Excuse me. Number 11, based on figure 2, what percent of PIPs grown in the CO2 concentration of 370 had died? And when it puts a word in italics, italics mean watch out. Because they've probably just flipped something on you. Italics means they're going to flip the question and make you try and say the wrong thing. So, died by 2003. All right, so we're looking 370, died 2003. So I'm looking over here, I got 2003. 370 is the solid one, so I'm looking, right about there. And that's 40, but that's 40% that survived. Yeah, they got you on a tricky one, didn't they? If 40 survive, then how many died? 60 died. Got to be able to do a little bit of math, know that 100% of everybody's going to live or die, so 40% survive, 60% die. If you see italics, they are trying to trick you. One left. According to figure 3, which plot produced a higher percent of S urushiol? This is actually I think this is the easiest question on the passage. Figure 3, higher S urushiol. S urushiol. Figure 3, which one was higher? 10 is higher than 5. Man, that's loud. So who was it? Present, 10%. Present, 10%. Answer option F. Notice also there was a present, elevated. We could have immediately crossed out the elevated, but I think that question's so easy. So let's look real quick at what you'll be working on for homework today. Got a very exciting first passage talking about trees. This graph's pretty good. I like this graph. God, that's loud. Hey, if you want to grow a tree, you had to have planted one. Pro tip. Passage number 2 is going to be talking about rocks, and it's going to let me say real quick. This graph of top right, you might not understand. I'm going to draw something by it right here. So what does this mean? I'm just going to tell you that does not mean that it's 70% sand. That means from 20 to 70% is sand. So that means it's actually, let me write that in there, 55% sand. So that graph is a little goofy to read, but when you see that bar there goes from 20 to 75 or so, that doesn't mean it's 75% sand. That means that part, take the difference, about 55% sand. So I will help with that. What else might we consider? Make sure you read this bit right here about what that graph means, because you've never seen a graph like that unless you're in AP Stats with me. Notice we got some pairs of answers, A, B, C, D. And on the last one, this last one is hard. Definitely use your pairwise things on number 37 and number 40. There's a lot of pairwise ones here. And also on number 38, you'll notice you have the greater than, less than, same as sort of comparison option. So a lot of similar sorts of questions to what I worked through in the in the video previous. So 3 passages a day. Again, it's about the work, guys. If you're putting in the work, marking up the text, you're going to get full points. You're going to get an A in this class. If you're slack-assing, then no slacking. I think we're done. Have a great weekend. The stuff will be due Monday, end of day.